see, there it started. So, what do you guys think of the new information?
I'm still slightly confused between the difference in law of Navier-Stokes and central theorem.
And I am too, but I think
it seems like the same thing to me, but I'm not sure.
yeah, we have to remember they're different, and I'm sure it will be on some sort of quiz because in his lecture that he gave, he kept talking about how important it was to know the difference. I think the biggest thing is that the central limit theorem has to do with the
normal,
the graph.
Yeah.
The graph. So if you can remember that it has to do with it having, the normal graph, then that should help you out. The law of large numbers, I think it doesn't necessarily mean it's a normal.
You have to it is related with accuracy.
Yeah.
Yeah. It has
what do you want with the law of numbers?
Accuracy and repetition is what I got from the law of large numbers. So as long as it has one of those words in the definition, I'll be able to figure it out.
Accuracy. I'm going to just write that just in case. And rep. Okay. I need to pull up my quiz because I closed everything down, but I'm almost to it.
No, you're fine.
Let's see.
And while you couldn't hear us, I told everyone I was really nervous about this quiz, so I've actually already gone through it, and it's not as bad as I was thinking it was going to be. So.
Oh, look at you. You're awesome.
I was nervous. I was like, crap, I don't know if I'm getting this. So.
All right. Quiz.
And I'm really struggling. I was struggling while I was reading the textbook of trying to remember all these Greek symbols.
I know. And all the new terminology with it.
Yes. So I printed the symbols reference, and it is sticking on like my wall that my desk is facing. So I have a reference always.
That's good.
I might not be able to use that in the exam that's coming up, but I'm leaving it there.
Are we going to read that one thing that was on the homework, like the distribution graph thing?
I don't think so. That was really fun though. I didn't get it until I watched the video, and I'm like, oh, okay, I get what they were trying to get us to practice and play with.
Mm-hmm.
But I didn't think so because they didn't have us use it in any of the homework or in this quiz at all. So I think that was just kind of an example.
Okay.
All right, so let's start the quiz. Question number 3. I guess I'll read it. When you are taking a sample size of 5 numbers, what is the shape of the distribution means histogram when the parent population is right skewed? So what is the shape of the distribution of?
I think skewed right.
It should be skewed right because the sophilus is only 5, and we've talked about the law of large number. It has to be 30
so
or
if
greater.
It's 30, it would be normal. Otherwise, it's just going to follow the parent population.
Yeah.
All right.
You got it.
Yeah.
Okay, skewed right. All right, Monica, you want to do 4?
I'll take.
Okay. Did you say my name?
Sure. Yeah, you can do it.
Yeah.
Okay. I didn't hear. When you are taking a sample size of 100, what is the shape of the distribution of means histogram when the parent population is right skewed? Normal.
Right.
Correct.
All right, Kayleen, you want to do 5?
Sure. When you are taking a sample size of 5, what is the shape of the distribution of means histogram when the parent population is normally distributed? And it is also normal.
Oh, I'm so glad these are really easy so far.
I know. So exactly. I was like, phew, okay.
Okay.
Charity.
When you are taking a sample size of n equals 100, what is the shape of the distribution of means histogram when the parent population is normally distributed? Normal?
Yeah.
Yes.
Okay.
All right, number 7 already. When would the distribution of means be normally distributed? Choose all correct responses. A says data are drawn from a population that is normally distributed and the sample size is small. That's true. B says data are drawn from a population that is normally distributed and the sample size is large. That is true. C says Data are drawn from a population that is right skewed and the sample size is small. That's false.
Mhm.
And D says data are drawn from a population that is right skewed and the sample size is large. That's true. So A, B, and D.
Okay.
All right.
Wait. Which of the following gives the best explanation of central limit theorem? First, if the parent population from which the data are drawn is normally distributed, then the sample mean will follow a normal distribution. That could be. For bell-shaped data, approximately 68% of the data will be within one standard deviation of the mean. About 95% of the data will be within two standard deviation of the mean. And approximately, I don't think that one is related.
No.
The 68, 93, 99.
Yeah. If the sample size is large, then the sample mean will be close to the population. I don't think that one. Then
No.
if the sample size is large, the shape of the distribution of sample means will be approximated normal. I don't know if the first one or the last one.
Let's look back in the book real quick.
I would put the first one because the central limit theorem has to do with the
But both have,
Yeah, I think it's the first one.
the last ones it talks about the sample size being large, and that would be the law of large numbers.
Yeah, in
I
the
think
book it says you have observed in simulations that if the sample size is large, the random variable x will be approximately normally distributed.
Is that the law of large numbers?
No, that's central limit.
Oh, it is?
Will follow a normal distribution. I think the key word is that distribution. So I still think it's A. I think that C, I think is a great example of the law of large numbers too. I think those bottom two are good definitions for all large numbers.
What she just read sounded just like D. Read that again, Charity.
You have observed in simulations that if the sample size is large, the random variable will be approximately normally distributed. And then it goes on and says, in other words, the sampling distribution of the sample mean will be approximately normal if the sample size is sufficiently large. This important result is called central limit theorem.
All right. This sounds ridiculously.
Oh, no, you're right. Yeah, I have a note in here, but yeah, I kind of quote it word for word.
The last one?
Yeah, the last one.
yeah, I think the last one.
Yeah, except I have written that the definition for central limit theorem is if the sample size is large, x, what's it called? It's x bar
X bar, yeah.
will
sample
be
mean.
approximately normal. So if the sample size is large, A is talking about the parent population. I get it. A is talking about if the parent population, something or other.
Oh, and it doesn't even talk about the parent
But
population.
central limit theorem says if the sample size is
Okay.
large,
So it's the last one.
bar will be a normal,
Okay.
That's a good
approximately normal.
sample size versus parent population. That's a good distinction to remember.
Yeah, so
Okay.
so we can D, right?
Yeah, D.
Okay, I agree with that. That is, I should write those words down word for word when we're done. Sample size is large. That's D. All right, next one. Who's up? Question 9.
I think I am. Let me go back up. Okay. Let X be a random variable with population mean as 10 and the population standard deviation is 6. Suppose that the sample size is 36, is drawn from this population. What is the mean of the distribution of the sample of means? And that's the one where it equals the same, so it should be 10.
Yep, that's what I would put. Right. And then Charity, are you after her? I'm losing track.
What is the standard deviation of the distribution of sample mean? Is that the one where we had to do the equation?
Yeah, this is when we have to calculate it. And I went ahead and put it in, I did an equation in Excel. I love Excel.
Okay, I'm gonna plug it in my calculator too. So hold on just a second. Okay. So it's O over square root of,
So what is it? It's 6 over the square root of
36, right? So essentially 6
36,
divided by
yeah.
6 is
Oh, so it's just 1.
Mhm.
And
Essentially,
So 1?
6 divided by the, yeah, so it's 1. So it's 6 divided by the square root of 36, and 6 times
Yeah.
6 is 6, so it's 1.
Okay.
I'm glad they make some of these equations really easy. You're like, oh, 1, that's not a bad number.
I know.
all right, number 11. Regardless of the distribution of the population, I just want to think about that wording. Regardless of the distribution of the population, if the sample size is large, what would be the shape? Normal.
Normal.
Yeah. Okay. What theorem will justify your response to the last question? It would be central limit.
Well, I'm going to think about this just in case.
Hold on. Let
I
me
think it's
look
the law
at
of
the large numbers again.
I think it's the law of large number because they're talking about it being greater than 30. And he says that
The
so
law
right now, for what we're learning, that's kind of,
that if the sample size is large, then the sample mean will typically be close to the population mean.
Let me check.
okay, it is not correct. It is not the law. It is the central limit theorem because
Central
I
limit
submitted it and
theorem
got it
states
wrong.
that if the sample size is large, that x bar will approximately be normal.
So it was
Yeah.
central limit?
So it is the central limit theorem.
But I want to reread it anyway, just to understand it. Oh,
So
right. If the sample size is large, because it says sample size.
Because
That's,
yeah, but it's talking about the shape. That's
Yep.
why I was.
yeah, I think it's the central limit theorem.
yeah. Sample size and shape are the key words there.
Because the law of large numbers is talking about the mean of the sample distribution or whatever, sample size.
So it is central limit theorem.
So
Okay.
in his weekly meeting,
Yeah.
he talked about it quite a bit, but I hadn't done any homework or looked at the chapter, so I was kind of confused by all of it. But I think if I went back and watched his video again, it would probably clarify those two things a lot more.
Yeah.
All
Yeah.
right.
I think it's just practice. Keep practicing, keep practicing.
There's two
Yeah.
things also from the video that I wrote down that you guys will want to remember. He talked
Oh,
about
it even said on the homework straight up, it has that sentence that we just did. At the, or not on the homework, at the bottom of the chapter, where it says review key concept, it says like question number 12, it has it on there, and I can't use it.
question number 12 for the homework.
Yeah, for the homework quiz. Or it like
Question.
11 and 12 together, it kind of has them. So it says, for this course, if n is greater than or equal to 30, we will say the distribution of the sample means will be approximately normal. And it's talking about the central limit theorem. So is that
Okay. For the next time we get together, there's two equations. There's z equals x minus mu over sigma, and there's z equals x bar minus mu over sigma divided by square root of n. He said in his video, you always use the second one. So the longer equation, he said, always use that one. And if there's no number, just pretend n is the number 1. And he said, then you won't get confused. But you'll get the answer wrong if you always use the first one, but you won't get the answer wrong if you always use the longer equation. So
Okay.
with
Which
that,
makes sense. The longer equation is probably going to be more accurate because it has more data. in it.
yeah, with that, always use the second one, well, the longer equation, and plug in the number 1 for n if you don't have a number to plug in.
Well, and essentially n is what he's talking about. So n goes back to like the probability that we learned where it always has to equal 1. So that's why it's the number 1, just to explain why. Maybe he does in the video, but
I don't know. I don't know. He just said the
Okay.
square root of 1 is always n, or is always 1, and therefore if you divide it by 1, you're going to get it as if that's not part of the equation or something. I don't know. Okay. Good. So, do you guys have any other comments, questions? How come I don't see this hangout all of a sudden? Hold on. Maybe it's on a different. Oh, here it is. Okay, good. Phew. Want to make sure I'm It's recording and you're stopping it on time. All right. I don't have any more questions, so
Me either, I'm good.
No, I'm good.
All right.
Thank you.
thanks, guys.
Thank you. We'll see you guys Thursday.
All right, bye guys.
Bye.